Hi my dear students, welcome back to Electron Academy. So today we are going to discuss about organic chemistry, and in this one of the subpart is isomerism. So without isomerism there is no JEE, there is no Neet question paper. So very important. For Neet we will get 2 to 3 questions for Neet. For JEE compulsory we will get 1 question from this. It is very important for JEE and Neet aspirants. So isomerism is divided into some subparts. In this today's session we are going to learn about isomerism 1. In this, first of all we will learn about the structural isomerism in this session. In structural isomerism we have 2 parts. So in this first isomerism part 1 means we will discuss about structural isomerism. So today topic is isomerism. So it is, which is very important for JEE and Neet. Compulsory we will get 1 question from this. Isomerism is very important. Compulsory you will get 1 bit for JEE, sure. JEE we will get 1 question, as well as Neet also you will get 1 question from this topic. Neet 1 question, JEE also 1 question we will expect from this topic. So actually, so today what is today our goal is, today's goal is what is isomerism and types of isomerisms we will discuss today. In this specially structural isomers, in structural isomerism, chain isomerism, positional isomerism, functional isomerism we will discuss today in this today session, right. So what are the isomers? What are the isomers and isomerism? What is isomerism? Simple, what are isomers first? Different compounds has same molecular formula called isomers. Simple definition, 2 different compounds having similar mass and their arrangement is different. Arrangement is different. So what is the arrangement, sir? Spatial arrangement or structural arrangement. So both are different there. Those are called as the isomers. Simple, isomers. Isomer is a Greek word. So it is a Greek word. Isomer is a Greek word. So in Greek, isos, it is a Greek language. So isos means what, sir, in English? Equal. Isos means equal. Next, meros. Isos, meros. Isos, meros. Meros means what? Part. So isomerism. Isos, meros called equal parts. Equal parts nothing but, so same molecular formula we have. Isomers are having same molecular formula. Same molecular formula, same, shortcut I am writing MF, molecular formula. Same molecular formula, different in structure or spatial or 3-dimensional arrangement. Different in structural arrangement or spatial arrangement. So this is called as the isomers. This phenomenon is called as the what we call isomerism. Sir, what is isomer? Same molecular formula, so different in arrangement, maybe structural or maybe spatial arrangement. These are called isomers. Isomer is a Greek word, that is isos and meros, right. So next, what? Types of isomerism. Types of isomerism. So what are the types of isomerism? Normally, see here, these are following types of isomerism. Isomerism divided into 2 types. Isomerism divided into what? 2 types. Isomers are how many types? 2 types. Number 1, constitutional or structural isomers. Number 2, stereoisomers. So first one, what? Structural isomerism. Structural isomerism. Number 2, stereoisomerism. Structural isomerism, stereoisomerism. How many types isomers? 2 types, structural and stereo. Again, structural isomers divided into 6 types. Structural isomers divided into how many types? 6 types. How many types are? 6 types. What are they? Simple. Number 1, chain isomers, chain isomerism. Number 2, positional isomerism, chain, positional. Number 3, functional isomerism, functional. So 3 over, chain isomerism, positional isomerism, functional isomerism. What are these? These are the type of the structural isomerism. Number 4, metamerism, metamerism. Number 5, what sir? Tautomerism, it is very important, tautomerism. Tautomerism very important for all competitive exams. So this is very important, tautomerism. 6th one, ring chain isomerism, ring chain isomerism. Sir, isomers are 2 types, structural isomers, stereo isomers. So in this, structural isomers again divided into 6 types. What are they? Chain, positional, functional, metamerism, tautomerism and ring chain isomerism. These are the 6 types. So in future we will discuss in depth. Next we are moving to here, stereo isomerism. Sir, what is stereo isomerism? So again these are divided into 2 types. Stereo isomers are how many types? 2 types. But structural are 6 types, stereo are 2 types. Sir, what are they? So those are conformational analysis. It is also very important, conformational isomerism. Next one, configurational isomerism, conformational, configurational. So this is here structural, this is stereo, stereo again divided into 2 types, conformational and configurational. So configurational isomerism again divided into 2 types, no confusion here, crystal clear. Configurational isomerism belongs to 2 types, geometrical as well as the optical, geometrical isomerism as well as the what we call optical isomerism. These are called what we call, these are called configurational, are also known as stereo, are also known as isomer. Step by step, optical isomerism belongs to configurational, then stereo, then isomer, isomerism, stereo isomerism, configuration isomerism, optical isomerism. Same here, geometrical isomerism. Geometrical isomerism also known as cis-trans isomerism, cis-trans isomerism. Optical isomerism also known as enantiomerism. So these are the double names. Geometrical isomerism also known as cis-trans isomerism. Optical isomerism also known as the enantiomerism. This is the types of the isomerism. Very simple. Types of isomers are 2 types. Structural are also known as constitutional or stereo isomer. Structural are 6 types, stereo are 2 types. This stereo, conformational, configurational, configuration again divided into 2 types. Very simple. So this is the types of isomerism, each and every part. So we will learn in next slides. Right. So in this first one we are talking about chain isomerism. So what are the chain isomerism? Chain. Structural isomerism I will start. So chain isomerism. So what is a chain isomerism? See, very important. Sometimes in examination they will give what are the another names also they will give. These are important beta. So chain isomers also known as nuclear isomerism, also known as skeleton isomerism. Chain isomerism, another names are what? Nuclear isomerism as well as the skeleton isomerism. So what is the definition of chain isomerism, sir? Chain isomerism what? Same, simple, in that name only there. Chain. So chain isomer means same molecular formula. Isomer means same molecular formula. So chain means what? Different in chain. Simple. So what is the definition? Compounds has same molecular formula. Compounds having similar molecular formula, but differ in what? Arrangement of carbon atoms, means different in chain. Different in carbon chain. Different in carbon chain. This is called as the chain isomer. Simple definition. So what is here? Same molecular formula. Same molecular formula. MF means molecular formula. So different in chain. Different in what chain? Carbon chain. So these are called as the chain isomers. Simple. This phenomenon is called as the chain isomerism. Right. Sir, example, sir. What compounds will exhibit the chain isomerisms? We can observe it in alkanes. We can first we have to check in this alkanes beta. So alkanes we can observe this alkanes. Example for chain isomers. For example, I am taking the formula C4H10. So it is in the form of what? Cn H 2n plus 2 form. So here I am writing here C4H10. C4H10 nothing but it is in the form of this formula. This is called alkane. So what we call here? Alkane we called. Right. So how to write the structural isomers for this? Simple. For example, I am writing CH3 bond CH2 bond CH2 bond CH3. So what is the name of this? So 1, 2, 3, 4. It is chain means we will use N. Straight chain generally we will use the N. So 4 carbons are there. This is a root word. So root word is what here? A root word or word root. So and it is a suffix. This is a suffix. So naming we will discuss in future. So N-butane here, N-butane. So N-butane and here this linkage is there. So this linkage is called, this structure is called iso. Generally, so 2 methyl groups attached to this carbon, it is called what? Iso. So this is called isobutane. So what we call it here? 2 are there. N-butane, isobutane having similar structure. What is that? C4H10. Count the carbons 1, 2, 3, 4. 4 carbons we have. Count the hydrogens 3 plus 2 5, 7, 7 plus 3 10. C4H10. Its molecular formula will be C4H10. So count the carbons 1, 2, 3, 4. C4. Count the hydrogens 3, 3, 6, 7, 7 plus 3 10. C4H10. So what is our definition? Same molecular formula there, but different in structural arrangement. That's why this is called as the, what we call here? So these two are considered as these two compounds having similar formula but different in where? So different in the structure. So these are called as the different in structure means chain here. Carbon chain is a different. So this is called chain isomers. These are called what? Chain isomers. Chain isomers examples, alkanes exhibit the chain isomers. Sir, generally in competitive exam they won't give this elaborated, they will give the bond line forms also. So how can you, they will give the bond line forms generally. So for example, I am taking this, just imagine this one, the 1, 2, 3, 4. These dots are carbons here. So these corners are the carbons here, 1, 2, 3, 4. This is equal to this. This is N-butane. Iso means generally we are taking like this. This is iso. So this is a isobutane, same. So these two they will give like this also, you don't confuse. So both are also chain isomers only. Both are also chain isomers. They will give the elaborated structure or bond line structure also they will give. So this is called as the alkanes. Alkanes exhibit the chain isomerism. Number 2. Sir, alkanes okay. Alkenes will exhibit chain isomerism. So yes, alkenes also exhibit the chain isomerism. I'll explain with, so this one example, C5H12. Sir, how can you recognize this? So C5, this is also example for alkane only, another example alkane only, N-pentane, isopentane, neopentane. Alkane example, another example, example 2 for alkanes. This is alkane only. Right. Now here new word there, that is neo. Previously N okay, I say okay. You have to remember N, iso, neo. Same molecular formula and this terminology there. First you check those are same molecular formula. Same molecular formula. This terms there. So directly you go and take the answer, that is chain isomerism. See here, this formula having C5H12. This is N-pentane. So this is iso group. So this is called isopentane. One carbon is attached to here, quaternary carbon this is. So this is also known as neopentane. So N-pentane, isopentane, neopentane or these three are called, what we call here? So what isomers here? Chain isomers. These are called chain isomers. This phenomenon is called as the chain isomerism. Simple. So alkanes exhibit the chain isomerism. Next, number 2. Right. Alkenes also exhibit the chain isomerism. Alkenes also exhibit the chain isomerism. For example, alkene means what, sir? CnH2n molecular formula there are double bond is there. CnH2n molecular formula there are double bond is there. So that is called as the, what we call here, alkene. So for example I am taking this. So numbering I am giving from here, this is a functional group, double bond is there means we have to give the least number for that. So first position double bond started nothing but which is called as the 4 carbons are there, nothing but it is called 1 butene. So here 1, 2, 3 arrange like this here, carbon arranging here like this, the structure will be different here. So same molecular formula, carbon chain is different here. So that is why these two are called as the, so what we call here, these are also known as the chain isomers. Chain isomers, alkenes also exhibit the chain isomers. Next, sir, alkanes okay, alkenes okay. Alkynes will be participates in, they will show the chain isomerism or not, sir. See, simply none here. So we are taking here normally. So what is the molecular formula for that? Cn H2n minus 2, there we call alkyne. Yes. What is the general formula for this alkyne? CnH2n minus 2 we know, or simply triple bond is there, what here, triple bond is also there, that is called alkyne. So for example I am taking 1 pentine, so this is 1, 2, 3, 4, 5 carbons are there. So first position ine there, 1 pentine, so 1 methyl group I am writing out of this thing, this is a major chain here, so I am writing the structure different here, structure means chain different specially. So structure means what beta, chain is different here. So nothing but here hydrogen means right. So 3 methyl 1 butane, the naming will be 1, 2, 3, 4, 3 methyl 1 butane. Simple, 1 pentine, 3 methyl 1 butane are what isomers? Same molecular formula, here we observed same molecular formula. So where is the difference, sir? So they are different in so arrangement of the carbons, different in chain. So that is why these are also example for chain isomers, right. Alkanes will exhibit the chain isomerism, alkenes will exhibit the chain isomerism, as well as the alkynes also will exhibit the chain isomerism, right. Next one, amines also will exhibit the chain isomerism, amines also. So first of all I am taking here NH2 I written here, okay, carbons are chain there here, right, and one more thing here, NH2 is here, 1 carbon I written here down, and here 2 methyl groups are chain different there beta in this. So what we have beta, these all are having same molecular formula, these all are having same MF means what, molecular formula. So different in what, chain. So chain is different. So that is why these are called as the chain isomers, that is it. Amines also will exhibit the chain isomers, right. Now I will give in bond line formula, you have to say chain isomer or not. Simple, what I said but a trick here, I will say the trick here, simple trick, how can you recognize these things. So simple trick to find out the chain isomers. So what is the trick means here, first of all I am taking this N iso neo, these terminologies are there, N iso neo, and you have to check the same molecular formula, check the molecular formula. If molecular formula is same and we have to use N iso neo, this terminology there. So these are called as the what isomers? Chain isomers. Easily we cannot see anything. Chain isomers. For example I am taking this. So which of the following is a chain isomerism? For example I am taking this N pentane. So what I am taking here, N pentane and isohexane. N pentane and isohexane. First example. Second example, I am taking here N-hexane and neohexane. N-hexane and neohexane. Number 3, N-butane, isopentane, right. For example, what I said here, what is the trick here, N iso neo. Sir, in all cases, N there, iso there, N there, neo there, N there, iso there. Sir, how can you check, sir, all are chain isomers? Means no. So first of all, what you have to check here, same molecular formula there or not there, you have to check. Simple. Here pentane there, here hexane there. One pentane there, one hexane there. Here pentane. Pentane means how many carbons we have? 5 carbons we have. Hexa means how many? 6. 1 means meth, eth. 2 means eth. So 5 means pent. 6 means hex. So N-pentane, isohexane, here carbons are not equal. So not a chain isomers, these are the not a chain isomers. Now, so I am checking a third example. N there, iso there, okay, it is clear. Now I am checking this, buta. So in organic chemistry, buta means 4, penta means 5. So different number of carbons are there. So but what is our, according to our definition, same molecular formula we have. This is also not a chain isomer. But what are the chain isomers here? N-hexane and neohexane there. So what I said, N-iso, neo there means what we call, that is the isomer, and same molecular formula there. Hexane, C6. Here also C6, same carbons are there. So hexane nothing but C6H14. Molecular formula is C6H14. Here also isohexane also C6H14. Same molecular formula there. N and neo there, or iso there. Those are called as the chain isomers. These are not chain isomers. What are these? These are chain isomers. So I think chain isomerism is the, so alkenes, alkynes, we have to check like this, chain isomerism, right. So I think chain isomerism is clear. So just I am reminding in easy way, what are the chain isomers? Same molecular formula but different in chain is called chain isomer. Simple. Alkanes, alkenes, alkynes, alcohols, amines, alkyl halides also can exhibit the chain isomerism. It is first part. Chain isomerism is crystal clear. So later we will discuss objectives on that. Next one, right, positional isomerism. Second one is what beta? Positional isomerism. In that name only there, simple. So very easy. Positional isomerism. Isomerism means same. We know iso means same molecular formula we have. So what is a positional isomerism? Position is different. What is a different? Position is a different. Same molecular formula. Compounds having same molecular formula, different in the position of the functional group. Different of the position of the functional group are called as the positional isomerism. Positional isomerism. The compounds with the same molecular formula differ in the position of the, so same functional group, whatever we are taking, alcohol or alkene, anything, so same functional group having, but that position is different, called as the positional isomerism. Simple, in that name only answer there. So for example, so here alkenes exhibits position isomerism, alkenes exhibits positional isomerism, alkynes also exhibits positional isomerism, and halides also, alkyl halides also exhibit the positional isomerism, alkyl halides, right. Sir, alkenes there, sir, how can you check the positions? Simple, here I am taking here 1 butene, 1, 2, 3, 4. So what we call here, this is called 1 butene. So 1 butene is the compound here, first compound. What is the molecular formula for this? C4H8. Now I am taking 2 butene. So what is the difference? So tell me what is the difference here? 1 butene, 2 butene. Sir, same molecular formula there. Same molecular formula there? Yes, same molecular formula there. So what is the different? Double bond position is the different. What is the different here? Double bond position is the different. That's why it is called as the, these two are collectively called as the positional isomers. So what we call these two are 1 butene, 2 butene are positional isomer. Here listen with 1 and 2, 1, 2, 3, 4, like that numbering there here. Numbering there means that is related to the positional isomerism. Next, C3H6 beta, alkynes also exhibit the same, alkenes as well as their double bond there, here triple bond there, that is the difference. Same thing, 1 butene I am taking as well as the 2 butene I am taking. 1 butene I am taking, 2 butene, these two also known as the positional isomers. Same molecular formula but triple bond position is different. Triple bond position is the different. So these are called as the, what we call positional isomers. So next one, alkyl halides. Alkyl halides how sir means here chlorine is a functional group here. What is your X? So alkyl halide means maybe chloride, fluoride, anything you take here. So here first position we have. First position chlorine is attached, but in this diagram second position attached, 2 chloropropane, 1 chloropropane, 2 chloropropane. Here listen, 1, 2, 1, 2, position is different. Okay, so there iso, neo, N terminology used in chain isomerism. 1, 2, 3, 4 numbering used in this position beta. So alkyl halide, 1 chloropropane, 2 chloropropane, these are called as the positional isomer. Simple. So first position here in there, here second position in there. Here first position in there, second position in there. Here what we have here, first position chlorine there, second position chlorine there. So alkenes, alkynes, alkyl halides, 3 exhibit the positional isomerism. Next, so not only in alkenes only, so these are called as the dihalides. Di means what? 2. So 2 halides are dihalides, 2 halides. So dihalides there means here if you have to check 1 and 2. So 1 comma 1 dichloroethane. So first position 2 chlorines are there, but here 1 2 dichloroethane. So same molecular formula. These are having C2H4Cl2. With this molecular formula same, but where is the difference there here? So different in the functional group position. So these are called as the positional isomers. Okay, single mono halides also can exhibit and dihalides also can exhibit. Similarly beta with formula C3H8O, these are called alcohols. What we call? Alcohols also can exhibit the positional isomerism. So number 1, 1, 2, 3, 1, 2, 3. So first position alcohol there, what is the name of this? 1 propanol. Here I arranged here, second position I arranged. So 2 propanol, 1 propanol, 2 propanol, or what isomer? Simple, 1, 2, same molecular formula there. These are the positional isomers, positional isomers. So this is one of the category, 1 propanol, 2 propanol. Next, this is about the alcohol. Next, we are moving to aromatic compounds. This is very important modalities. Aromatic compounds. We know that 1-2 position substitutions are there. 1-2 position substitutions are there. What we call beta ortho compound it is. So 1-3 position substitutions are there. What we call beta meta M. Ortho also known as So what we call here ortho nothing but 1-2 position. Meta nothing but right. Meta nothing but 1-3 position. Next para. Para means what? 1-4 position. 1-2 position what we call but here? So this is called ortho, meta, para. Ortho, meta, para with similar formula. Similar molecular formula there. Ortho, meta, para and similar molecular formula there. Those are also positional isomer. Why sir? Ortho means 1-2 position, meta means 1-3 position, para means 1-4 position, 1-2, 1-3, 1-4. These are also known as the positional isomers. So this is called, benzene ring connected with 2 methyl group called xylene, orthoxylene, metaxylene, paraxylene. These 3 are considered as the same molecular formula but different in the position of the methyl groups called positional isomers. Positional isomers. So alkanes, alkenes, alkynes, not alkanes here, see back side, right. Not alkanes cannot exhibit positional, alkenes, alkynes, alkyl halides. Next dihalides, alcohols and aromatic compounds. So these are the positional isomers, right. Not only this, so this one, what we call, these are called ketones. C double bond O group there means ketones also exhibit the positional isomerism. So ketones also exhibit the positional isomerism. Sir, what are the ketones sir? C double bond O group is there. So what is the general formula for this? R C double bond O R. So this is called symmetrical ketones. R C double bond O R dash called unsymmetrical ketones. So now simple I am taking here C double bond O there here 1, 2, 3, 4, 5. So second position owned there 2 pentanone. Here third position owned there what we call beta 3 pentanone. 2 pentanone and 3 pentanone. These are what isomers? So 2, 3 numbering there, simple numbering there means positional isomerism. Here second position functional group is there, here third position functional group is there, same molecular formula we have. These are called as the, what we call here positional isomers. So position isomerism exhibiting, we will check here one by one. So positional isomerism exhibited by, positional isomerism in number 1 alkenes will exhibit the first one what? Alkenes exhibit the positional isomerism, alkenes S. Number 2 alkynes also exhibit the positional isomers. Number 3, alkyl halides also exhibit the alkyl halides. Alkyl halides also exhibit the positional isomerism. Number 4, alcohols also exhibit the positional isomerism. Number 5, ketones also exhibit the positional isomers, ketones, and few of aromatic compounds also exhibit the positional isomerism. So positional isomerism we can find out in this. Sir, what is a trick, sir? Trick. So what is the trick? In easy way, how can you learn the positional isomerism? First of all, we are taking this. So simple trick beta here. First of all, you have to check anything isomer, nothing but same molecular formula. So just to check the numbering beta, 1 position, 2 position, 3 position, 4th position, or ortho, meta, para, like this there means these are called as the positional isomerism trick. N iso, these are positional isomerism. N iso, these terminology there, N iso neo, these terminology there what we call chain isomers. These are called what beta? Chain isomerism. This is called chain isomerism. So positional isomerism, chain isomerism. So both over. Now we will see, I will give you some example. So I will give the time you have to solve these things. Right. Number 1. So first compound, this and this one and this one. What isomers these are? Number 2, these are called bond line structures. Second example. Now third example. This is a benzene ring. So here is a chlorine, ortho, meta and para. So first two are what isomers? Simple, these are alkanes. This is called what group here? Iso group here N. This is iso. This group is called iso, and this one will be N. So iso N, same molecular formula there. These are called what isomers? Chain isomers. So next here, and double bond is a functional group here. This is a functional group, 1, 2, 3, 4, 5. Third position keto group is there, 1, 2, 3, 4, 5. So here fifth position keto group we have. So third position and second position, not fifth position, second position we have. So third position, second position, position different there means these are what isomers? Positional isomers. Simple, positional isomers. Ortho, meta, para there. This is a ortho dichlorobenzene, meta dichlorobenzene, para dichlorobenzene, no doubt at all. These are also positional isomers. So simple. So 2 over, these are the structural examples. First one chain isomerism over, second one positional isomerism over. Now we are moving to functional isomerism, very important for all competitive exams. Sir, what are the functional isomers? Functional isomerism, which is the third isomerism, which belongs to structural isomerism. Sir, simple, in this name only there, functional isomers. Functional group is different. Iso means same. Iso means what? Same molecular formula. So no need to learn, no need to by heart any examples, any definitions like this. Simple, same molecular formula. So different in functional group. So functional group will be different. These are called as the functional isomers. So what is the definition? The compounds with the same molecular formula but different in the type of the functional group. So they possess are called as functional isomers, and isomerism between them is known as functional isomerism. This phenomenon is known as the functional isomerism. So simple definition, what? Same molecular formula but different in the functional group. So previously what? Same molecular formula different in chain, same molecular formula different in functional group position, but here we are different only, functional group only different. Sir, what are the examples? Very important. So we will expect question from this. Functional isomerism, we will expect question from JEE or Neet, any competitive exam. This is most important. Right. So, for example, first one we will take alcohols ethers. Alcohols ethers are functional isomers. Number 1, aldehydes, ketones and unsaturated alcohols. Aldehydes, ketones and unsaturated alcohols also known as the functional isomers. Number 3, acids and esters. These 3. First pair is what pair? Alcohols and ethers pair. Second pair is what? Aldehyde, ketones and unsaturated alcohol. Third pair is what? Acids and esters. Acids and esters, alcohols and ethers, aldehydes, ketones and unsaturated. Unsaturation means double bond. So, double bond with OH group is there. This is called as the, so these are the best examples. For example, one by one we will check. Right. First one here we will go with alcohols and ether. First of all, you have to learn about this. CnH2n plus 2O is a general formula for this. CnH2 ethers as well as the alcohol having similar formula. And here 2n2O na, here just 2NO. CnH2nO is belongs to aldehydes and ketone. CnH2nO2, these are called as the acids or esters. Acids or esters, right. So, first of all, what is the general formula for alcohols and ethers? What is the general formula, sir? Simple. So, CnH2n plus 2O. CnH2n plus 2O. Right. Sir, we cannot substitute the 1. If you substitute the 1 only, ethers we cannot make it. Ethers minimum 2 carbons required for ether making. So, N is equal to 1, not possible. N is equal to 1, ethers not possible. Methanol will come as alcohol. N is equal to 2 also, we cannot, yeah, N is equal to 2 onwards. So, this one, for example, ethanol and so for example, here I am taking from here C4H10O here. So, for example, I am taking N is equal to 2, C2H6O. What is the formula? C2H6O. I am writing 2 things here. One is the alcohol. What alcohol we can make? CH3, CH2OH, ethanol, or CH3O, CH3, dimethyl ether. One is alcohol, another one will be the ether. Alcohol and ether, so both are having same molecular formula but different functional group. These two are called as the functional isomers. So, example here, this is a alcohol, butanol, alcohol. This is a methyl propyl ether. These two are collectively called as the functional isomers. Same molecular formula, that is C4H10O. Alcohols and ethers are called as the functional isomers. First example. Now we are moving to second examples. Aldehydes, ketones, unsaturated alcohols. Sir, for example, I am taking, what is the formula here? CnH2nO. CnH2nO. So, minimum ketone formation, minimum 3 carbons required. So, N is equal to 3 onwards only, so they will exhibit, the ketone will form, N is equal to 3. If you take N is equal to 2, so aldehydes we can make it, but this one, ketones we cannot make by using this 2 carbons. So, minimum carbons to show the functional isomerism, that is equal to 3. So, right, C4H8O, what we are taking here? C4H8O, so I am writing here butanaldehyde, okay, or butanol. So, aldehyde is there, or butanone, butanol as well as the butanol, these two are we are preparing by using this. So, what we call better here? Functional isomers. And one more thing, unsaturated, here unsaturated alcohol, enol also known as, double bond there na, double bond there means what we call better ene, OH there ol, enol. So, what and what are functional isomers? First one aldehydes, second one ketones, third one enol. Aldehydes, ketones, enol. Aldehydes, ketones, enols are called as the functional isomers. Third one, acids and esters. What is the general formula? CnH2nO2. Here CnH2O, 1 oxygen there, but here 2 oxygen there, that is called acids and esters. Acids and esters, right. C4H8O2, so that means here acid group and ester group. COOH is called acid group, COOCH or C double bond O, CH3 is called as the esters. So, acids and esters, these are belongs to functional isomers, right. Next, fourth examples. Cyanides, isocyanides. Sir, cyanides and isocyanides also belongs to functional isomers. Nitro compounds, nitrites, nitrites, amines, 1 degree amine, 2 degree amine, 3 degree amine. These are also examples for functional isomers. So, first we are taking about here fourth example, cyanide. Sir, what is a cyanide, sir? RCN. Sir, what is the isocyanide, sir? RNC. Same molecular formula, but functional group is completely different. These are called nitriles also. These are called carbyl amine also. You don't confuse. Nitrile they will give you in word formation. They will give you nitrile. Nitrile and carbyl amine also they will give you. So these are also known as the functional isomers. Here see, C triple bond NRCN, cyanide. NC molecular formula similar only. See, four carbons, 3 carbons, cyanide and NC, same thing, structure is same, same molecular formula, different in functional group. These are called as the functional isomers. Next, nitrite, here nitrite, NO2 group is there, nitro, RNO2, RONO. Same only here, 2 oxygens there, 2 oxygens there, 1 nitrogen there. So R group is a similar. Nitro and nitrite, NO2 group, ONO group is there. Nitro, nitrite. These are also known as the functional isomers. Next one, amines. 1 degree amine, 2 degree amine and tertiary, 3 degree amine. 1 degree amine, 2 degree amine, 3 degree amine. These are types of the amines. These three are also known as the functional isomers. So see here, sir, what is a 1 degree amine? Nitrogen, amine group is, nitrogen is connected to single carbon here. Here nitrogen is connected to 2 carbons here. Here single carbon, here double carbon, here 3 carbons are there. This is tertiary amine. 1 degree amine, 2 degree amine, 3 degree amine. So both are having, these three are having similar molecular formula but different in the functional groups. These are called as the functional isomers. This phenomenon is called as the functional isomerism. So finally, so what are the functional isomers? You have to memorize this. So first one beta with this formula, CN H2N plus 2O. Next formula will be, so here two things will possible, alcohols possible as well as the ethers possible. Alcohols possible, ethers possible. Next one, second one, CnH2n O, CnH2nO. What possibilities we have? So carboxylic, sorry, 3 possibilities we have. What and what here? Aldehydes, we can make aldehyde by using this formula, ketones and unsaturated alcohols also known as enols. Next, CnH2nO2. So we can make 2 things. What and what here? By using this acids, carboxylic acids, esters. Carboxylic acids, esters, both are having the similar formula. And one more thing here, very important here. So minimum here 2 carbons required. Minimum, how many carbons required? Minimum carbons required, minimum carbide requires, right. So minimum carbides are 2 carbons required, minimum, right. So for example, I am taking N is equal to 2 possible beta, minimum carbons, minimum, right. Here ketone formation minimum 3 carbons required. So compulsory you have to start with N is equal to 3 only here. So below 2 there means that cannot exhibit the, so functional isomerism. Next, here carboxylic acids and esters. So esters also minimum 3 carbons are required here. Here also N is equal to 3. 3 above there only, 3 carbons are above 3 only there. So these are exhibit the positional isomerism. So these are exhibit the positional isomerism. For example, here I am taking C2, okay, C2, H, 2 2s are 4, 4 plus 2 8, C2 H8O possible, C3 H8O possible, C4, 4 2s are 8 possible. What possible? functional isomerism we can make alcohol ethers possibility there. But if you take C2H6O is possible now, C1 means not possible here. So C2H8O is possible, C3H8O possible, C4H10O also possible. Now come to here beta. If you put n is equal to 2, so what do we get? C2H4O, C2H4O. C2H4O means, yeah, here also possible, n is equal to 2 you take, CS not possible here, we cannot make the ketones. Ketones minimum required this one, C2H4O cannot possible for positional isomers. Positional isomerism not possible in this. Positional or functional isomerism. So functional are not possible. Functional isomers, these all are functional isomers. Now n is equal to 4 I am putting. C4, 4 2s are 8, C4H8O possible means possible, C3H8O possible as R means possible, remaining all are possible. Now come to the carboxylic acid, CnH2nO2. So ester formation minimum 3 carbons required. For example, here I am taking C2H4O2. We can write the carboxylic acid by using this, but we cannot write the ester. That's why it cannot form the positional isomerism. So C3H8O2, here possibility there. What possibility? C4, C3H6O2, C3H6O2, 3 2s are 6. Right. Next one. Right. These are called as the functional isomers. What do we call here? Functional isomerism. Right. So now next one. So what is a chain? What is a chain isomerism? What is mean by chain isomerism? Simple. So total conclusion of this class. So what is a chain isomerism? Sir, same molecular formula we have. So what do we have here? Same molecular formula we have. Same MF. MF means what? Molecular formula. But different in what here? So but different in chain. Carbon arrangements different in chain are called as the chain isomer. What is the trick here? Trick. Same molecular formula N iso neo. This terminology there, that is called chain isomers. This is number 1. Number 2. Right. Positional isomerism. What are the positional isomers? Tell me. What are the positional isomers? Simple. Same molecular formula we have, but different in same molecular formula, same MF, but different in position of the functional group. Different in functional group. FG means functional group position. So what is the trick here? Same molecular formula there, as well as the, what is the trick here? So N, 1 numbering there, 1, 2, 3, also known as ortho, meta and para. Next third one here, positional over now. Next functional isomers. Same molecular formula but differ in the functional group. So functional isomers are what? Generally functional isomers are same molecular formula but differ in where? Same molecular formula but differ in functional group. Here functional group position, here functional group only. So what are the examples here? Alcohols and ethers. Alcohols and ethers are functional isomers. Aldehydes and ketones and enols also known as functional. Acids and esters, carboxylic acids and esters. Nitro compounds and nitrites, nitro and nitrite. Cyanides and isocyanides, cyanides and isocyanides. Right, nitro, 1 degree amine, 2 degree amine, 3 degree amine, 1 degree amine, 2 degree amine and 3 degree amine. So these are also known as the chain isomers, positional isomers, functional isomers. So we will discuss some points on this. See, for example, I will give you some compounds. So tell me what are the functional group in this. For example, I am taking N-pentane. Okay, what is this? N-pentane, isopentane or what isomers? N-pentane and what isomers are this? Number 1, first question. So, second question is butanol, not ol, here butanol. So, butanol and butanone, are what? Number 4, orthoxylene, paraxylene, and paraxylene are what isomers? What functional isomers are? So, positional or China, in these 3 only answer there. Next, fifth example. Sorry, 1, 2, 3, fourth example. This is a third example and this is a fourth example, right. Right, next one. So, do this, right. So, first is what is the answer? First one, N-pentane, isopentanes are what isomers? Yeah, correct. So, these are the, yes, your answer is right, N-pentane, isopentanes are the chain isomers, right. Next, so butanol are what? Yes. So, that is a correct answer. What isomers here? All and one means functional. So, functional isomers. Orthoxylene and orthopara will be the, yes, positional isomerism, all correct. So, first one chain isomerism, second one functional isomerism, third one positional isomerism. These are called as the, so this is today's session, right. What we finished? Positional, functional as well as the chain isomerism. So, this is today's session, right. Bye bye.